3rd. Yay! Oh, wouldn't it suck if the eclipse was cloudy?
It would, but I'm going to try and find like a friendly school bus driver who's willing to like chase like openings in the clouds, and we can all be little kids fighting to have the back seat in the bus bouncing along on the Illinois roads.
Right. So we've got like, people out there telling us where the bright spots are, and we book it.
Yeah.
Either downrange or uprange to the place that's most likely.
Carbondale or Mizzou. We can go in either direction. I have friends at both.
Yeah. So, I'm trying to think how far we could get, with about 6 hours of notice. I'm sure we could find a place that's got like a clear spot, right? 6
hours notice, you can legitimately get 150 miles.
Yeah. And so, in either direction, uprange, downrange. So, we're just for people who are wondering, like, what the Susan Hunter says, let's ask Sophia. Perfect. Let's all get on board the airplane, go above the cloud tops, and then we get to follow the eclipse track.
Except Sophia doesn't have any windows, so really we don't want to do that.
It's got a telescope, but yeah.
Yeah, but you can't look at the sun with it.
Yeah. No, it's not our idea. Anyway, so we're just talking about what we're going to do for the eclipse, and it's definitely turning into we're all going to hang out at Pamela's home city of St. Louis / Southern Illinois, Edwardsville. So somewhere in that range. And so if that's a thing that you want to do and you want to come and hang out with us in Edwardsville, like we're talking low key here right now.
Mm-hmm.
I think you're looking to maybe find some places that'll reserve some blocks of hotel rooms at sort of a reasonable price. And who would think to go to St. Louis in the middle of August as a vacation spot? So it shouldn't be too expensive.
The hotel that we work with is the Moonrise Hotel, which is in the Loop District of St. Louis. And I'm going to find some good campgrounds to recommend as well. And it's going to be one of these things of we're going to try and get a room at the Moonrise because they have a great room up on the roof where we can hang out, chill, talk science. I'll bring in some local people to talk about the area. And we'll do the things that I love to do because that makes it fun.
Mm-hmm.
And so details are coming. We're working on getting the block of hotel rooms set aside right now so that things are a reasonable rate for people. But yeah, we're going to make this shit happen.
Yeah. And I think we'll, like as more people come on board and more people propose some things, that maybe we can add other stuff, right? Yeah. Like maybe we'll all meet at some observatory, or maybe we'll go to a dark sky park that's in the region and we'll get, a local astronomy chapter to set up. And who knows what we're going to do? Maybe the Planetarium will let us do a show and do a talk in the show.
I know we do.
Yeah, so something at the university, whatever. I mean, we can figure out some stuff and sort of make it entertaining. But what I want to avoid is this being like a great big dragging con.
No,
you know what I mean? Like we just want to be like a bunch of us friends hanging out, watching an eclipse.
Yes.
Okay, so I'm going to say hello to a bunch of people who have said hello to us. So I'm going to say hello to Bob Cain.
Is that like a relative, perhaps?
That is my dad. My dad is watching live. So hi, Dad.
Adorable.
Giselle Sabarin, Guido Bibra, Learning Space,
that's me.
Okay. Michael Meyer, Nancy Graziano, Susan Hunter, and Tony Phillips. So, hey everybody! I know showing up at a really weird time. One other piece of addendum, which is that I'm going to be in Las Vegas on Friday during the Weekly Space Hangout. So I'm going to be trying to find some wacky internet. However, we've got a very important guest on Friday, so I've really got to make this work. So I'm going to definitely make good internet happen when I get to Vegas. How hard could it be?
It's surprisingly challenging.
I know. Okay, cool. So let's see. Is there anything else to go into?
I just have to say, I love seeing the Australians. because we're recording at a really weird time, we
Yeah.
have Australia
Yeah.
in the house, and this
Oh,
is
right
kind
on.
of cool.
Yeah,
And
I
you
see a
all get
bunch
to
of.
see my campus office, which I don't think you've seen in ages. And the empty shelf is because we're hiring people, and my office is going to be shared. See, there's a it doesn't rotate that far. There is an empty desk next to my desk, except we're actually storing chemistry equipment on the shelves behind it right now. So my office is prepared for one of the new people we're going to hire to join me as my office mate. And so if you are looking for a job, go to cosmoquest.org/open-jobs, /x/open-jobs. And we have a bunch of positions open right now, looking for all levels of education. We are generally looking for people who are already in the United States, because trying to do visas is difficult. But if it's a really, truly amazing candidate for one of our postdoc positions, we will do the paperwork for international.
Like perhaps someone from Canada.
If someone from Canada had all of the characteristics we need and applied, yeah, we can hire a Canadian.
Okay, all right. A few more people jumped in. So we got Curtis Corbett, Martin Brochu, Peter Leverdink, Sam Whitestead, Steve Bartholomew, Susan Hunter. So, hey guys. So let's begin our episode of Astronomy Cast.
That sounds good.
Yeah. Okay. Did you want to mention that again in?
Yeah, I probably should.
Okay. Are you going to be? Are you going to have that? You have that URL in front of you just to be safe?
I now will remember the /x.
Okay. Okay. Well, I'm going to press record whenever you're ready.
I am recording with the wrong device. Let's try again.
No.
I'm sorry. Sorry. It's not the right computer.
Johnny Zed, hey, and Nana Yao Ofori, yo, and Carl Pemberton, hey. Welcome.
Test.
It's your first live stream. I hope it's everything you hoped it would be.
Okay, I'm pressing record, testing. Why do I see nothing?
Any hint on the special guest? Nancy, can I say who the special guest is? Is there any reason why I can't? Jerome Moten. I'll let Nancy Grazino tell me whether I can say the special guest. Okay. So it
pressing
is.
Record again. Testing. It's working. Okay, I got it this time.
Oh no! Well, then I guess I won't be able to say who the special guest is.
Do you want me to stop?
I'll give you all a hint. He killed Pluto and found Planet 9. Okay, tell me when you're ready.
Okay, so now I'm stopping. I'm deleting. I'm pressing record. It's recording. Hello, Preston. And this is Preston's last season. So if you have loved his work, send a postcard to us at SIUE, and we will bury him in postcards of love.
Aw, that's so cute. Okay. And we need to find a replacement editor.
I'm already on that. Don't worry about it.
Okay. Yeah, I've got some names I can throw your way as well. Okay. Hello, Preston. You can hear this part. Should we re-record this so he doesn't hear this part?
Sorry, that's true.
Yeah.
Okay.
All right.
Pressing record a third time. It's recording. Hello, Preston.
Hey, Preston. Okay. Let's get on with the show. Welcome to Astronomy Cast. It's an episode number. I am so terrible. Do you think 409 times I would be able to do this? Okay, here we go. Astronomy Cast, episode 409, Spin in the Solar System. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well, and we're coming today, for me at least, from a weird location. For those of you who are either watching this on YouTube or I guess
Your,
watching us on YouTube.
your work?
Yeah, I'm on campus today. So if the internet is a little weird, if the audio is a little weird, it's because I'm using the mic that we bought in 2006.
Wow.
Yeah, so I've pulled out the old tech, and if you're watching this, you can see that one of the shelves behind me is completely filled with stuff, and the other shelf has a phone in it and is otherwise completely empty. And it is empty, waiting for one of our new hires to come and start sharing my office with me. So if you are looking for a job, CosmoQuest has a bunch of jobs open right now, and you can read all about them at cosmoquest.org/x/open-jobs. We have jobs for all education levels, and for the PhD positions, if we get a really good candidate from abroad, we have the ability to do visas. We need people soon because I don't sleep enough.
This is so weird. Normally you are asking, people for money, and now you're begging to give money away.
It's true. We after many years of struggling to keep everything going, our hard work, our efforts, it's all being rewarded, and we have this chance to grow. And so we watched our last postdoc, Nicole, go on to get a tenure track position up in New Hampshire, and she's doing great. And so we're ready for someone new to come in and not fill her shoes, because that's not possible, but to take on new positions, doing new things within CosmoQuest.
Yeah, they're very noisy shoes. So that's fantastic. I mean, I am so looking forward to the next couple of years. We're gonna have such a wonderful opportunity to help, really share our love of science and astronomy, and bring in this community that's been standing by our side for years, but now we've got budget to be able to work on science projects and outreach and research. It's going to be a really exciting time. So go check out the URL once again, Pamela.
It is cosmoquest.org/x/open-jobs.
Perfect. And let us give you a job. All right, let's move on to the episode. So the solar system is a spinny place. Everything is turning. But if you look closely, there are some pretty strange spins going on. Today we talk about how everything started turning and the factors that still impact them today. All right, people like listening didn't see me do the little air quotes when I said impact, but that was a dad joke about them getting smashed by things. All right, let's get on with the show. So tell me about sort of like when we look at the solar system, everything is kind of in this line, right? It's all lined up and everything is spinning, and it's mostly spinning in the same direction.
Yes.
So what got all that squared away?
It was something that is called the solar nebula model, because astronomers are really bad at giving things cool names. And the solar nebula model basically says that our solar system, and pretty much all other solar systems, originated as a giant cloud of gas that once upon a time was probably nice and stable, but then got gravitationally knocked, shocked, changed in some way, or otherwise shocked, and the shock wave caused the gas that had been stable in a cloud to condense just enough that it went from being supported by the gas pressure to being collapsed under the gravitational force of this now slightly smaller cloud. And if you shock a cloud of gas anywhere except on its exact center of mass, it's going to start spinning. This is true actually of pretty much anything. Anything you hit, unless you hit it exactly along its center of mass, is going to start spinning. This is why in car crashes you see things spin left or right unless you hit them exactly on the center of the bumper or fender or whatever. Once you start something spinning, it naturally flattens out. This all angular momentum is a fascinating thing that terrifies students taking vector physics. But it's the reason we get pizza that is flat. You spin something, it flattens out beautifully, and our solar system and that pizza dough conforms to the exact same physics and flattened out. And as stuff within that spinning pizza dough solar system, as it condensed out, it kept that spin until it got hit by something else later on.
Right. Okay. So, and isn't part of it as well, and maybe I'm, making stuff up here, but like every particle in that gas cloud has its own motion.
Yes.
If you look really closely, each one of these little molecules of hydrogen, whatever, is kind of, moving through this gas cloud, and they're kind of orbiting each other. And as you connect them all together with gravity, then you kind of average out the total movement of the whole collection, and that also gives you spin, right? And you need to, as that collapses down, you're going to get that angular momentum as you average it all out.
So in that initial cloud that formed the solar nebula, prior to getting shocked, hit, condensed, whatever triggered that initial collapse, the motions of the molecules and atoms in that cloud and the dust particles were pretty much completely random. It was thermal motion. Once it started moving, however, you have gravity affecting that motion, and gravity is trying to pull all of those atom molecules, dust particles down into the center of that mass distribution. But you have conservation of angular momentum going, no, we're going this way, and we're going to spiral in, or actually orbit, instead of falling straight in. It's sort of like if something is on a bicycle going in a circle, or better yet, on a merry-go-round. If you try and walk from the outer edge of a merry-go-round in towards the center of a merry-go-round, it's hard. It's hard to walk in that straight line, because what you're standing on is moving, because you have angular momentum, because it has angular momentum. And that same difficulty, that same fighting this fake force that you deal with trying to go in towards the center, the same momentum that you have to figure out how to get rid of, it affects things in that collapsing gas cloud as well. So as gravity tries to pull these originally randomly scattered particles in towards the center, their angular momentum from the thing spinning after it's been shocked forces them to not fall straight in, and instead end up in a spinning disk.
Right. Okay. So the whole thing comes down, it collapses, it starts to spin up like a big pizza dough. It flattens out, but then how does that affect the planets, and then I guess the spin of the planets and the spin of the moons as well?
So initially you have all of the bits and pieces of stuff that are forming in this disk. Everything's spinning in the same direction. But as the stuff is colliding as it goes, you end up with occasionally torques end up happening where one massive object might gravitationally knock something else that isn't perfectly spherical around because of torque. It's a fancy way of saying if you look at your door and you push where the doorknob is, it turns really easily. If you try and push where the hinges are, it doesn't move as easily. The force at a distance that you're acting on that door is called torque. That's what that force is. But it turns out that if you have a spinny thing that you try to set spinning and it's not perfectly spherical, it's going to orient itself so that the biggest deviation from spherical is along the center. This is why tops are pointy on the bottom, fat in the middle, pointy at the top. Doesn't work the other direction.
So if you put, I'm just trying to think, if you had like a great big top and it was sort of, big, long, flat top, and then you put a bunch of little tops on top of that big top, and you started the big top spinning, I mean, obviously those little tops would want to zip away, but if you could somehow get them from moving away, they would start to turn. I wonder if they would turn in the same direction as the big top.
It's Coriolis forces. It's the same reason that we have our winds move the way they do. There actually are, because of the motion, effects that do cause unified rotation in opposite directions on the two hemispheres.
And then the moons is just a microcosm of that. And so the moons would rotate on, in following the same rules that the planets would rotate. There's following the same rules as the whole solar system is gonna rotate, and the moons of the moons would rotate, and the storms on the moons would rotate. All, everything in a perfect universe, in a perfect solar system, it would all be rotating in sort of lockstep in the same proper direction.
It's true, but we don't live in that solar system.
Right. We've got all kinds of things that broke the rules. So let's talk about what removes spin, right? So we've got these, instead of having these moons which spin nicely, we've got all these moons that are locked to their planets.
So this is that big nasty force called torque. Torque will gravitationally, tidally lock a moon to its parent body. So what we end up with is, so here I have Planet Coffee Mug. And Planet Coffee Mug, it has a big handle on the side of it. And if it's trying to rotate so that the coffee stays in the cup, so the opening to the coffee cup is straight up, bottom of the coffee cup is straight down, and it's rotating around that axis so that the handle is going around and around and around. Well, that handle on the coffee mug, it's a bulge. It's an anomaly on my non-perfectly spherical moon. So if I take planet moon coffee mug with a handle and I place it near the much more massive travel mug without a handle. This is my desk. It's covered in mugs. This is a true story.
Yeah, we know.
So
a lot of coffee flows through that office.
So as moon coffee mug with a handle orbits around travel mug without a handle, that handle is constantly getting gravitationally torqued towards travel mug without a handle. And eventually we end up with the handle of mug with handle constantly being faced towards our planet coffee mug without a handle. So that extra mass anomaly is naturally going to get torqued. It's naturally going to get constantly gravitationally rotated and pulled so that it's facing towards the massive nearby object, in this case, large travel mug without a handle. With our own moon, it doesn't have a handle, but what it does have is an off-center center of mass, which is kind of a strange thing to say.
But gravity makes its own handles, right? I mean, there are tides. The moon is reaching out to the Earth and squishing the oceans to make handles on both sides, and the Earth did that to the moon with its soft, squishy, rocky parts.
But the crazy thing is, the Earth will actually rotate the moon so that its handle is facing the Earth. So if we had coffee mug with a handle as an actual moon and it started out with that handle at some crazy angle, over time, as the moon rotated, it would get torqued, not just so that the rotation stopped, but so that the handle went from being at some crazy angle pointed at our planet coffee mug without a handle. That handle would slowly get torqued. The rotational axis of that moon would get changed until the handle was constantly facing towards the Earth. And this is what happened with our moon.
Right.
Our moon had its rotation rate changed and probably its axis changed so that its biggest mass discrepancy from a perfect sphere was constantly pointed at our planet Earth.
Right. And if the moon didn't already have one of these things, the gravity from the Earth was going to squeeze one out and then grab onto that and yank it in the direction. I don't know. Have you ever seen you rotate something with a magnet on it and you spin it around a couple of times and then it just stops pointing with the magnet at the thing that you're directing it at. So that explains the moon, Our moon, the moon.
Well, and what's
Um,
awesome is it actually explains some really weird anomalies with Pluto.
Explain how.
so so this is one of the things. The idea for the show came from, I had no idea what we should do for a show. I was out of ideas. So I started flipping through my notes from the Lunar and Planetary Science Conference last week. And they're really trying to figure out the weird mass shape oddity that is Pluto. And looking at it, the big heart, there's thoughts that that might actually be a crater, and it created an anomaly in the mass distribution of Pluto, and Pluto may have actually changed its rotational axis in response to Charon so nearby, so that its mass anomaly after the collision had the bulgy bits facing over towards Charon.
Right. Yeah, I mean that's the crazy part, right? Is that Sharon did that to Pluto, and Pluto did that to Sharon, but all the other cases, right? Jupiter has wrenched every single one of its moons, except for I think some of the outer ones. Same with Saturn, same with Neptune, same with Uranus. They've all taken their moons and found or made a handle and are yanking on it to the point that those moons have to show the exact same face to the planet. So that explains those situations and it helps maybe uncover like what's going on with Pluto. But then there's some weirder places in the solar system that spin in ways that kind of defy comprehension. And so what are some places where the spin is super weird?
Venus. And there's actually some really great random posts on Tumblr of all places about you think you have trouble understanding the basics in life, and then you realize we don't know why Pluto's standing on its head. Not Pluto, Venus. We don't know why Venus is standing on its head. So because most of the stuff in our solar system all is rotating in the same way, so that if you were on the surface, sun rises in the east, sets in the west, north is in the same orientation. We have this, if you're looking down on the world and you see that it's rotating following the right hand rule, your thumb points north. And this is how we define north, is with the right hand rule. And with Venus, it turns out that its pole is kind of pointing straight down. So it's like it's giving the whole solar system a thumbs down. It's a opinionated little world.
Right. So the day on Venus is, and I forget what the number is now. It's like 200 and something days, 240 days, but it's backwards.
It's super, right? It's rotating super slow. It's upside down.
Yeah.
And we've been trying to figure this out, and there's a bunch of different ideas, and we talk about all of these in our episode on Venus. But it's something where it's either torque from the planet Earth, it got hit in the past, and the sucker's covered in clouds and hard to understand. So we don't know. And
right.
It's awesome. This is why we study worlds, and this is why we need to send another spacecraft to Venus.
Right. So it could very well have just gotten smashed by something large. It could just be the interactions with the gravity of the Earth that flipped it over but didn't flip us over. Cool. It might have the way we got a moon, right? The thought is like we had a Mars-sized object crash into the Earth and that blobbed out a moon. I wonder what kind of object it might take to smash Venus upside down. But then stop it, right? Because like, why would it be completely upside down? Would it have had to have hit perfectly on its alignment to start to counteract its normal rotation and have it spinning the other way? Did it, what caused it to flip over like once, or maybe it kept flipping a bunch of times and then finally slowed down to what it is today? And maybe anyway, I'm just mindlessly speculating. So please put me out of my misery.
And what's fabulous is, as we look around the solar system, we see multiple examples of, well, that world got hit hard. Vesta literally took it in the South Pole. And I mean that quite literally. Something very big smacked the asteroid Venus, created a giant, unpronounceable crater. And this effect crumpled Vesta, created wrinkle ridges. And this change in the mass distribution of Vesta caused it to change its spin axes so that where those bulgy wrinkle ridges, that became the equator. It wasn't that way before. It wasn't that it just got precisely hit in its south pole. It's that the mass distribution changed, and this most likely changed its rotational axis so that the bulgy bits lined up with the equator.
Whoa.
Yeah. Now you look at Mars. Mars, we talk about how its two hemispheres have radically different altitudes, the highlands and the lowlands. And there are many different models that actually speculate that this is due to a massive hemisphere cratering where something massive hit Mars and created those lowlands and changed the tilt of the world. And we know that the spin axis of Mars isn't entirely stable because it doesn't have a massive moon to stabilize it the way we do. And so its poles get to wander. And this makes uncoupling all of these different effects a bit challenging. But when we map out where we see subsurface frozen water using neutrons, we're able to see what look to be historical evidence of past different locations of those poles from where ice is trapped in the soils, where it condensed into the soils as a North and South Pole when the poles were in very different places.
Right. Yeah. This, like, we can see these evidence, these ancient ocean coastlines and seas on Mars, and it's entirely possible, right, that in the ancient past Mars just kind of flipped over a little, and the position of the seas had to change to balance with the position of Mars. So some really interesting evidence, as you said, the distribution of ice under the the surface, the shape of the ocean coastlines on Mars, that just leaves evidence that it has made some pretty major movements in the past.
And when we try and understand the history of our solar system, we have to take into account all of those coffee cup handles, or in the case of Mars, the giant volcanoes, the mountain ranges, the valleys, all of these things that are deviations from being perfectly spherical. Because all of those deviations are handles that gravity can use to torque around those worlds. And the sun's gravity creates a torque. This is why our own Earth has precession, and every 26,000 years our pole is pointed. It completes a circle. And as all of these torques are taking effect, the different worlds, they wobble, they rotate, and Jupiter is yanking us around. Saturn is yanking us around. It's different amounts of yank because of all of the different distances. But we have to sort all of this in our long-term climate models for the different planets.
Explain Neptune.
Yeah, no. I think it's Uranus that's actually the really troubling one.
Uranus is the one that's flipped over on its side. That's right.
So Uranus actually wants to point its pole straight at us, part of its orbit, and its equator at us, another part of its orbit, because it keeps its pole more or less pointed at the exact same stars. And while its pole stays pointed at the same stars, it goes around the sun. So we go from seeing its North Pole to seeing its equator to seeing its South Pole. But basically, it's on its side. Something knocked it, torqued it. We don't know which. We don't know what combination. Something caused that ammonia gas ball to fall over.
The thing that I love is that, when you look at the orbits and you look at the rotations and the spin axis of all of the objects in the solar system, they're all a little off.
Mm-hmm.
Like Mars is whatever, Earth is 23.5 degrees. Mars is roughly similar. Uranus is on its side.
Our solar system's a violent place, and we forget this.
Yeah, there were countless interactions through the billions of years where these worlds came into contact with each other and mess with each other. So I want to sort of talk about some of the weirdest spinning objects in the solar system. And these are some of the smallest bodies, the asteroids, and they break all the rules.
Oh, yeah. Heck, Rosetta, what it found with Chirigiri 67, that's a duck-shaped couple of blobs of ice attached with a neck and not rotating in a sensible manner. So we find things that are shaped like rubber ducks. We find things that are shaped like dog bones, and they haven't had time to spin stabilize. You'd kind of expect that if something is shaped like a dog bone or a kitchen spoon or is otherwise oblong, that it would probably either happily rotate around its long axis or maybe rotate around its center of mass in like a single plane. But what we find is they're actually kind of tumbling, and we often have to use light curves that take into account multiple axes of spin to fully try and understand their motion. And what always gets me is we do these, we make plans. Currently, we have a plan, and the plan is we're going to build this awesome little spacecraft called OSIRIS-REx. It has the best name of any spacecraft ever, as far as I'm concerned, and you're not going to change my mind on that. So we're building this awesome little spacecraft with an awesome little name, and we're going to send it to Bennu. And Bennu is a little tiny asteroid. It's kind of similar to the one that the Japanese visited, Itokawa, and we're going to go and we're going to land on little tiny Bennu, and we're going to pick up a rock and we're going to bring the rock back to Earth.
Yep. Rock Stealer. I think I probably call the mission the Rock Stealer, but anyway, sure.
We don't know how that rock is precisely rotating. We have a good idea from measuring its light curve. We think that this isn't going to be too big of a challenge. Again, the gravity is so low that by landing, I mean grabbing onto it and stabbing into it and holding on tight, not being gravitationally held on. That doesn't happen with things this tiny. So we could always get there and realize that there's some weird albedo effect that caused us to like not fully understand how crazy shaped and strangely rotated this sucker is.
So why are these asteroids rotating so weirdly?
Because they hit each other. This is I saw
there's more to it than just them hitting each other, right? The sunlight.
Well, there's that too. So we have lots of different effects. I saw a great tweet. Sandy Springman retweeted it. I forget who wrote it originally, but you can find it in her Twitter feed. And it said, when mommy and daddy asteroids want to make baby asteroids, they slam into each other with great violence and create small parts. And this is how baby asteroids are made. And so you have, on one hand, things slam into each other on a regular basis, and this creates different spin. This creates things that fall apart and gravitationally come back together. We also have the problem that if something isn't a perfectly smooth coloration, the sunlight hitting it, the different parts of the asteroid will reflect light differently. And that will cause it to spin differently as you get more reflections off of some colors and more absorption from other colors. There's all sorts of different effects that keep these things spinning, keep them moving, all sorts of different things. And it creates chaos. And then there's the Nice model that says there was a point in our solar system's past when Jupiter and Saturn were in resonance, so that for every one time Saturn went around the sun, Jupiter, which is closer in, went around twice. And this created a gravitational slinging of bits and pieces in all directions that led to the age of the heavy bombardment, led to Uranus and Neptune getting flung to outer orbits, and rearranged our solar system kind of in whole and in pieces, and created the pieces.
Right. I love that idea, though, that, was it the Yorp effect? And I forget all the parts of it, right? just this idea that the asteroids are getting hit by sunlight, and the sunlight, there is, different parts of the asteroids, different colors, are heating different levels, and it's giving off radiation, and that's causing a thrust onto the asteroid, but at different speeds. And so they, over time, as the sun hits them, they spin themselves up into completely random spins that are entirely chaotic. It's an amazing effect that really can only happen on the smallest things in the solar system. So,
and it's something that we have to take into account when we start considering spacecraft, when we start considering building bases that are going to be specific colors of whatever their materials are. And heck, if something's coming our way, we can paint it.
Yeah.
And change its orbit and change its rotation.
Yeah. Cool. Well, thanks, Pamela. Thanks, everyone, for watching. We'll talk to you next week.
Sounds great. Okay, I need to be over-caffeinated more often when we do this.
I think I'm perfectly caffeinated.
So Georgia and I went to IHOP for lunch on the way back from the Challenger Center, and I got banana strawberry pancakes and drank way too much coffee.
Or not enough coffee. Whatever is the perfect amount. But you like being over caffeinated? Okay. All right. I think we've got some time for some quick questions.
Yeah.
Got some good ones in there. Hold on. I look for the question mark. So definitely everyone gets into the practice of using the question mark. That's awesome. Mike Brown is the answer. Yes, we're gonna have Mike Brown on Friday, and his co-discoverer of Planet 9.
Who we all need to remember his name, other than it begins with KOL. I need to learn the rest of the letters in his name so I can say it.
Yeah.
I feel bad that we keep saying Mike Brown's colleague, because that's
Mike Brown's
really
colleague. Yeah, Mike Brown and the other people. Yeah, I know.
Yeah, that's horrible of us. We are going to work to fix this.
Yeah, I will drill into it. But I've talked to Mike Brown quite a bit in the past, and he is a riot.
He is. He and I got to get dinner at the Rio IAU a million years ago when he had just killed Pluto, and that was awesome.
Yeah, and it's funny because that is like not his absolute priority is Pluto.
No.
Like he's most interested in
Europa
and icy bodies, closer into the solar system. So Curtis Corbett says, does the spin of the Milky Way tend to skew the spin of systems within it to align? So is there any connection? No. So there's no,
not that we found it. Binary stars appear to be randomly oriented on the sky.
Yeah. So astronomers have looked. Okay.
We look for these things.
Yeah.
And I saw a question earlier along those lines about galaxies. And if two galaxies formed out of the same parent gas, they will have the same rotation. But if they formed out of separate bodies of gas, they will have random orientations of direction.
Right. And astronomers have looked for this at the largest scale of like, is there any preferred rotation in the entire universe?
And we don't find it.
What we do find is there's a preferred rotation in human beings.
Yes. We want everything to be going clockwise.
Yeah. So human beings have this weird bias, but apart from that, let's see. Sondi is working on OSIRIS-REx. Although I don't think we're allowed to say. Are we?
No.
Yeah, okay. We're not allowed to say. I have to talk to the public relations people at OSIRIS-REx and really clarify Sonny's role and how the Weekly Space Hangout and OSIRIS-REx. And
they have nothing to do with each other. She's doing the Weekly Space Hangout on her personal time.
As a fan, just a space nerd.
So I'm gonna bemuse people. Within reach, Coffee Mug 1, Coffee Mug 2, Coffee Mug 3, Coffee Mug 4, and these are the ones I can reach.
I can reach duct tape. That's about it. That's crazy. Okay. Let's see. Steve Bartholomew says, started watching you guys about a year ago and finally caught up to the live show starting from episode 1.
Oh, wow. You've watched over 200. You've listened to over 200 hours of us.
Yeah, 10 years worth of episodes. And have you gone and like started in on Learning Space or the Weekly Space Hangout or the Guide to Space? Or yeah, we
You forgot to do the tie-in for your show.
well, I'm gonna do it the other way around. In the Guide to Space, I'm gonna be tying in
And
last week's episode of Astronomy Cast.
record a Casper episode before you leave for Las Vegas.
Why don't we do this when we shut this down then? Or
Okay.
I can just do it, right?
Yeah, if you can just do it, that would be awesome.
No problem. Thanks, Casper. Every day,
sarcastic.
every day that no, seriously, every day that I'm going to be in Las Vegas in some crappy bed in a hotel, I'm going to be wishing I was sleeping on my Casper mattress.
Is true. I went to LPSC and actually was in serious pain when I got back.
Yeah. So casper.com/astro.
DearHilton.com, can you please get Casper mattresses?
Oh, they should totally just go in for like a collection for the whole hotel. That'd be great. They're so good. Okay, I think we're good.
And we get
Larry Beckham is only up to episode 369. That was a great episode, I think, because they're all great, obviously. Okay.
And I just have to say, this is not a planet.
Have you seen the pictures of Pluto where they've drawn on?
Yeah, those are awesome.
It's perfect. Clearly, if we get together in St. Louis, we've got to make pancakes.
It's true.
Yeah. Okay. All right. Well, I think we can wrap this up because I got to record 2 more episodes of Guide to Space shortly. We're going to be doing,
and I need to do laundry because I'm going to the Astronomical Society of the Pacific board meeting, and I need clothes
and more coffee.
Yes.
All right. Konstantin Batkin is the colleague who's going to be joining us.
Excellent.
Devastation 421 found you guys a few months ago, caught you late and live. Thanks. Well, you can just go back to the beginning of the episode and pretend like you're watching it live, and then in the end you're like, hey, Fraser just said my name live on YouTube. So Devastation 421. Okay, let's wrap this up. Thanks everyone for watching. Look forward to my shenanigans as I try to find internet on Friday. And we will see you all back on Monday with more Astronomy Cast goodness.
Sounds great.
All right. Thanks, everyone.